All right, we're on to Unit 8. So this is the series unit. First question, which of the following is absolutely convergent? And so we have two different ways we can go about proving absolute convergence. We can use the ratio test or the root test, because when those are convergent, they're absolutely convergent. Or we can use the alternating series test and just check to make sure that the absolute value of the function is also convergent. So what I did is I just kind of went through and did some tests initially just to see if these functions, if ignoring the minus, the -1 would make, if they would be convergent or not, because then I knew that, you know, the alternating series test was going to work for the absolute value part of it or not. So here I could see that this, well, actually I kind of ignored A, but this one, this is the P series test. If you ignore that, P is 1/2, and so that is divergent, so I knew it wasn't B. For this one, we had this, and I went ahead and I said compare it with root k over k, which would simplify to 1 over k to the 1/2. And 1 over k to the 1/2 again is divergent, and so I knew that when I did I'm trying to think if it's direct. You could do direct comparison or limit comparison, but either way it was going to be divergent, so I knew it wasn't C. Looked at this one, I was going to compare it with 3 over k. Again, P series, P equals 1. That's going to be divergent. And then the last one is actually this right here. You could rewrite as 3 over k. K to the 1, k to the 1/2 is k to the 3/2. So as it is right now, this is a P series where it is convergent, and that's just ignoring the fact that that's negative. So I know the absolute value of the function is going to be convergent. And then I went ahead and I did the alternating series test. So I was saying the limit as k goes to infinity would equal 0, and that is true. And then if I made these plus 1s, would that be less than or equal to if they weren't plus 1s? That was true. So the two conditions worked out, so I knew the E was the answer. And I guess because of that, I didn't go back and check A, because I knew the E was right. All right, so this next one, it converges for which values of x? It looks like you can see that the center of convergence is 0 because there's nothing in parentheses to put it somewhere else. Pretty good chance that the radius is 1 based on these answers right here. So if you were in a crunch for time, you could go back and just check the endpoints. But if we want to go through the whole process just to make sure that they got the radius right, then we can go ahead and do that. So if you guys remember, when we check for the interval of convergence, we typically do the ratio test. You don't always have to do it, but it's the one that generally works. So I said the limit as k goes to infinity of x to the k plus 1 over k plus 1 divided by x to the k over k. And this is an absolute value, so it does absolute convergence. And then this is the limit as k goes to infinity, and I'm going to go ahead and just flip the bottom up. So x to the k plus 1 over k plus 1 times k over x to the k. And then we can go ahead and rewrite this one. So this is x to the k times x to the 1. And the x to the k's cancel. And so that leaves you with the limit as k goes to infinity of x times k over k plus 1. And since the k's are the same size and the 1 is negligible, then this is just x. And so we know that for the ratio test it converges if this, whatever your limit happens to be, is less than 1. And so, so now I know, since my center is 0 and my radius of convergence is 1, I know that the interval is -1 to 1. So I know it's B, C, or D. I just have to check the endpoints to see if they're included or not. So I'm going to go ahead and check -1 first. So that gives me -1 to the K over K. And so when I did this one, I went ahead and did the alternating series test on it. So I said the limit as K goes to infinity of 1 over K is 0. The limit as K, just kidding. And then I said 1 over K plus 1 is less than or equal to 1 over K. True, true. So -1 works. And then I went ahead and I checked +1, so 1 to the K over K is just 1 over K, and that's a P series where the P value is 1 and that diverges. And so that told me that the answer was C. Okay. Which of the following power series is the expansion for x times cos x minus 1? So I just went ahead and I wrote down what cos x was. So cos x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, etc., etc., etc. And then there's a -1 on the end, so I did that. And then it has an x in the front. So I knew the ones would cancel. And then I went ahead and I distributed my x. So I've got -x to the 3rd over 2 factorial plus x to the 5th over 4 factorial minus x to the 7th over 6 factorial. And then I checked my answers. So it's not going to be A, it's not going to be B, those don't have the factorial. C looks like a good candidate. Oh, the signs are wrong. D is probably it. E is definitely not. So it's D. You could go ahead and check your factorials just to make sure they make sense. So 2 is 2 times 1. Yep. 4 is 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. Yep. And I don't really feel like checking that one because it's bigger. So, all right. What are all the values for which this series converges? So if you look, a number to an exponent this is a geometric series. So that means that what is in here, this is the R value. And we know that the absolute value of R has to be less than 1. So I wrote 5 over 9 minus A has to be less than 1. And you could even maybe just plug numbers in and think about it to solve it and get your answer, but I'm going to go ahead and show you the mathematical way. So anytime you have something where this is less than 1, it means that it's going to be in between -1 and +1, right? Which is what we know about the R values, is that they have to be in between -1 and +1 for them to work. So I wrote 5 divided by 9 minus A is less than 1 but greater than -1. And then I set up two inequalities and I solved them. So -1 is less than 5 over 9 minus A. 5 over 9 minus A is less than 1. And then when I did this, I went ahead and I had those switch places. So 9 minus A is less than 5 over -1. And then I went ahead, so that's -5. So I subtracted 9, so I got -A is less than -14, and then A is greater than 14. I think technically, when I switch these places, I think the sign switches twice because you've moved a -A over here, but you've moved a -1 over there, and you did both of them with multiplication or division. So the symbol, when I did it the first time, my symbol was kind of off. I was like, that symbol didn't make sense. But you can still just kind of think it through and make sure that your numbers work for that. Just plug them in and make sure that the overall fraction is less than 1. And then on this one, I kind of did the same thing, so I switched them. So I said 5 is less than 9 minus A. subtract the 9 over, I get -4 is less than -a, and I get 4 is greater than a. So a has to be less than 4 or greater than 14. And so it's E, and I kind of plugged some of those numbers in just to make sure that they made sense. All right, number 5. So the Maclaurin series for 1 over 1 plus x squared is this. What is the Maclaurin series for tan inverse? And this is something that I did not remember to put in my packet with my notes, but I did kind of remember this from when we learned the unit, was that this right here is the derivative of tan inverse. And so integrals and derivatives kind of held true with this property. So if I know what the derivative is, then I can just integrate this, and then that will give me the Maclaurin series for tan inverse, which is cool. So I went ahead and I just integrated -1 to the k, x to the 2k dx. So I took the -1 to the k and I moved it to the front because that's a coefficient. And then I just did what I know about the integral rules. So I added 1 and I divided by that. So -1 to the k times x to the 2k plus 1 divided by 2k plus 1. And that is b. Make sure to put the notation in front of it. Here it doesn't really matter because it's multiple choice, but if you ran into something like that on a free response question, you have to make sure you go back and put the summation sign in front. All right, Maclaurin series represents which function? So here I kind of had to think about things. I automatically got rid of sine because sine only has odd exponents, and I could see that this one had even exponents. And then I knew that if it was raised to the second power, it was, it was going to, actually, I guess those would have become even. Maybe don't eliminate that one right away. E would be odd. Actually, they kind of do it so they'd all kind of work. Well, what I did is I kind of had a gut feeling that it was going to be cos. So I wrote out the Maclaurin series for cos. This is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And then what's really important about this is looking at the just the overall pattern. And so once I had this, then I kind of thought through like, okay, let me think about plugging each of these things into it. So if I have 3x squared being plugged in for x, and that would be -1 to the k, and then 3x squared. Actually, I guess I could. These are all in k's. Let me do k instead. To the 2k over 2k. And then I thought, is there a way for me to take this and make it look like that? Because I was looking at it and I was like, okay, well the 3 is being squared, so I could kind of see the 9 there. So what I did is I split apart this 9. I thought of this as -1 to the k times 9 to the k, and then x to the 4k. And I was like, well, let me think about rewriting this x squared to the 2k, because I wanted it to match this over 2k factorial, and I felt pretty good about this being the right answer. I want to say I actually checked c first, and I realized that c was, because of the 9, that's why I checked c, and then the 9 was going to get too big. And then I took the 9 and I rewrote that as 3 squared. So 3 squared to the k. So I can see this this is 3 to the 2k, there's a 2k out there. So when I saw that this exponent 2k and that exponent were the same, I was like, oh, I can write those together. So -1 to the k, and then 3x squared to the 2k over 2k. And those are the same, and so that tells me that it really was a. Now what you could have done is you could have done all of these and just like written out the first few terms and written out the first few terms and compared them. But this I think is a good way to do it a little bit shorter if your brain can kind of track with what you're doing there. It takes a little bit less time. All right, they give you the first 5 terms. They want us to solve for what the third derivative is, so I know that that comes from right here. So I wrote out f triple prime of 0 times x to the third divided by 3 factorial is what gave them 3 over 4 x to the third. So then I said, okay, we know that f triple prime of 0 divided by 3 times 2 times 1 is 6 equals 3/4. And then I went ahead and multiplied the 6 to the other side. And I got f triple prime of 0 is 18 over 4, which is 9 over 2. All right, which of the following series diverge? So for the first one, I went ahead and I decided to compare it with k to the 3 over 2 divided by k squared. And when you simplify that, that is 1 over k to the 1/2. So that's a p series, and p is 1/2, so that diverges. So then I did the limit comparison test with that. Actually, can you do direct comparison? I mostly just never do direct comparison because I can't remember the inequalities, so I always do limit comparison. So the limit as k goes to infinity of this more complicated one divided by the more simple one. I don't think it's absolute value. And then go ahead and flip the bottom up. So I know that when I multiply this all out, the leading coefficient is going to be what matters, because when I distribute this, that's going to give me a k to the 7/2 on top. When I distribute this, it's going to give me a k to the 7/2 on bottom. And so the highest exponent of k is the same size, and they're going to cancel out. So I knew that this limit was 1/5. And the limit comparison test tells me that if I do get an actual limit for this, then whatever the conclusion was up here, it holds for the other one. So, so I know that number 1 is divergent. The second one, I went ahead and just did the nth term test. What was if it doesn't equal 0, it diverges? Oh, I didn't do the nth term test. I did the alternating series. Sorry, guys, wasn't quick enough there. All right, alternating series test, I said the limit as k goes to infinity of 1 over ln k is 0. 1 over ln k plus 1 is less than 1 over ln k. That's true. So I knew that number 2 converges. So that was good, because I know that's not an answer. And then for number 3, I went ahead and did the root test. So the limit as k goes to infinity of -1 to the k times 4/3 to the k. This isn't an absolute value sign. So I got rid of the k's. This wouldn't be the nth root, to be the kth root. It's messing me up. This entire thing was in terms of k, and we always did it in terms of n, and it's messing with my brain. All right, so the k's are gone then, so it's just the limit as k goes to infinity of -1 times 4/3 an absolute value sign. So it's just the limit as k goes to infinity of 4/3, which is 4/3. And so the conclusions of the root test said that if it's less than 1, it's convergent. If it equals 1, it's inconclusive. If it's greater than 1, it's divergent. And so that means that 1 and 3 are the 2 answers here. All right, the next one wants us to do the 6th degree term of the Taylor series expansion. It's centered around 0, so it's actually a Maclaurin series. And this is e to the x. So I went ahead and I wrote out e to the x. So that's 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial. And we just know that when we do plug in the negative 1/2 x squared in for x, we want to make sure that we're getting to the 6th degree term. So we want to get to where the exponent for the x is a 6. So 1 plus negative 1/2 x squared plus negative 1/2 x squared over 2 factorial. And that's going to be an exponent of 4, so I need to do the next one. And then this is the one that I'm dealing with here. So what I did is I knew that the negative 1/2 raised to the 3rd power is negative 1/2 times negative 1/2 times negative 1/2. That is negative 1/8 x to the 6th over 3 factorial. I knew that 3 factorial is 6. So this is negative 1/8 times 1/6 x to the 6th power. So that's negative 1 over 48 as the coefficient for x to the 6th. So that's A. All right. On this problem, they're kind of getting at what the standard or what the error is, the error bound. So if you can see, f of 2 is e to the negative 2. This t sub n of 2 is our approximation of what e to the x is when you evaluate it at 2. So if you do the actual number evaluated at 2, subtract the approximation evaluated at 2, you get the error. And so what I wrote is I said the error is the absolute value of f of 2 minus t sub 6 of 2. And so, so that's what 2 to the 7th divided by 7 factorial is it is the error specifically for this. So I knew that it wasn't A. And I knew that it wasn't going to be B because B is the backwards version of this, so it's going to be the same number, the same distance. However, it's going to be the negative version of that, and the negative version of that is definitely going to be less than the positive version. So I'm going to table these two for now. I knew it wasn't this one because this one should be more precise. And so, so it would be even smaller, for sure. And so then now I have to consider these two. So for these two, this one, since it's the backwards version, that would be a negative number, and so that's definitely not it, because a negative number is always smaller than a positive number. So, but this one, the error for this one would be 2 to the 6th over 6 factorial, which would be not less than that one, and so the answer is C. All right, 11, I'm ashamed to say I got this one wrong because I started doing the problem and then I missed the derivative. I read it when I first did the problem and then I totally forgot about it. So I went ahead and I started writing out the points, or the function itself. So 3 plus 2 times x plus 5 times x squared over 2 factorial plus 4 times x to the 3rd over 3 factorial. And it said 2nd degree, so I was like, oh, let me cover this up, and then let me plug in 0.1, and I'm done. And that was an answer choice, mind you. And then, and I looked back and I was like, oh, it's the derivative. So the derivative of 3 is 0, derivative of 2x is 2. This is 5 over 2, so if you multiply 5 over 2 times 2, you get 10 divided by 2, which is 5. So 5x to the 1. This is 4 over 6. So 3 times 4 is 12. 12 divided by 6 is 2, so that's 2x squared. And then I was like, aha, that's a degree of 2. So now you can go ahead and plug in the 0.1. So 2 plus 5 times 0.1 plus 2 times 0.1 squared. And when you do it this time, you get C. All right, so here we've switched back to not being able to use a calculator. Number 12, the Maclaurin series represents which expression below? And I wasn't able to narrow down a lot. This one I kind of thought through like the process I had used for the last one to kind of help me. So I knew that it wasn't b because -5 was repeatedly multiplied, like more and more times, and this one would just be once each time, because that -5 was just going to be distributed. I got rid of the answer for D with the same reasoning. Also the +2 on the end, which wasn't going to have anything. I got rid of E because the +2 in here, when you, that should have been somewhere inside this X, and I didn't see it, and so I got rid of that one. So I kind of narrowed it down to be between A and C, and then I figured it was A because on the bottom it was K factorial, not 2K plus 1 factorial, which we would expect to see with a sine, and not a 2K factorial, which we would expect to see with a cosine. So I felt pretty good about it being A, but I just wanted to make sure. So what I did is I wrote down what the pattern was for e to the x, which is, do those alternate? They don't normally alternate, but they will this time. So I wrote down that it was x to the k over k factorial. And then for that, you're going to go ahead and be plugging in -5 x to the third to the k over k factorial. And you're going to have an x squared that's in front of that. And so then I wanted to split it up to make it look like this. So I went ahead and I took the -5 and the x to the third and I kind of put those apart. So that's -5 to the k. And then we have an x squared, and then we have an x to the third to the k over k factorial. And so this is x to the 3k. And since you have x to the 2 times x to the 3k, that's x to the 3k plus 2, because you can add those exponents together. And so A was a good answer. It was the answer. All right, 13. What are the first 3 terms? So as long as you remembered that, you'd be good. So sine is x minus x to the third over 3 factorial plus x to the 5th over 5 factorial. So I went ahead and I subbed the x squared in there. So x squared minus x to the 12th over, went ahead and used 6 because of the way that they are writing out the answers, x to the 10th over, so 5 times 4 is 20, 20 times 6 is 120. Oh, and then these are not the answers, although they do have it in, oh, they don't have it in there. It says f prime of x, so now you have to take the derivative of that. So f prime of x, that's 2x minus 12 over 6x to the hopefully you guys noticed this one, I didn't. 2 times 3 is 6. I was getting ahead of myself. Alright, so 6 to the front, 6 over 6, x to the 5th. I was like, this isn't right. 10 over 120, x to the 9th. That's just 1. That's 1/12. So it matches up with D. Sorry about the confusion there. My bad. Not redoing the video. Alright, next page. Alright, which of the following series is conditionally convergent? So, what I did first is I kind of looked at functions where the absolute value of the function would still be convergent, because then it wouldn't be conditionally convergent, it would be absolutely convergent. So, when I looked at A, I was thinking, oh, you can use the nth term test on that one if you ignore the -1. if I use the nth term test, the limit as k goes to infinity is infinity, so this one is divergent, and you ignore the -1, so it's like, okay, that's not helpful. On this one, you have 1 over e to the k. That's actually, you could rewrite that as 1 over e to the k. So that is a geometric series, and this is an r that's less than 1, so this one would have been absolutely convergent, so that gets rid of b. For c, if you compare it with 2 over k, 2 over k is divergent because that's a p series and p is 1, so that doesn't really help me. For d, you can do the nth term test or the kth term test in this case. It's infinity, so that's divergent, so that didn't help me. This one, you can compare it with k over k to the third, which is convergent, and so when I did that test, I found out that that was convergent as well. So these two are absolutely convergent, which, you know, helps, but that only narrowed it down to 3 answers. And then I got kind of stuck, and then I was thinking, well, conditionally convergent means that the alternating series test must have worked. And then when I had thought of it that way, I realized that the only one that fit was C. Because all 3 of these are divergent without the -1, but with the -1, C is the only one that passes the alternating series test. The only other tests you could do to prove convergence are like the ratio test and the root test, and those are specifically for absolute convergence. So, so A and D are out because the alternating series test didn't work for them. All right, radius of convergence for the power series. So again, we're going to do a ratio test on this one. So the limit as k goes to infinity of x to the 2 times k plus 1 over k plus 1 times 4 to the k plus 1. And then we go ahead and take the bottom and flip it up. X, so that's x to the 2k plus 2. 4k plus 1. So then I rewrote some of this stuff so I could see what canceled. So this is x to the 2k times x to the 2. This is 4 to the k times 4 to the 1. And so x to the 2k canceled, 4 to the k canceled. So that left me with the limit as k goes to infinity of x squared times k over k plus 1 times 4. And I can see that the k's are the same size in there, so they're going to cancel out, and that left me with x squared over 4, which converges if this ratio right here, this fraction, is less than 1. So then I went ahead and I multiplied the 4 over. X squared is less than 4, and I square rooted. So the radius of convergence is 2. So the answer is C. So when we do the radius of convergence, we can multiply numbers over to the other side, we can square root. But if it said like x minus 5 or something, we don't do that because that has to do with the center. We don't want to move the center. But we can multiply and we can square root and do things like that. All right, moving on to the free response question. You can use a calculator, which is always fun. So first, they want you to show that it converges for all x, and so that's the ratio test. They want you to find that the radius of convergence is infinity. So, part A. Radius of convergence. All right, so said the limit as k goes to infinity of -1 to the k plus 1 times k plus 1 plus another 1, x to the 3 times k plus 1 over k plus 1 factorial. Then we can go ahead and flip the bottom one up. So we've got a few things here that we can rewrite. So this negative 1 is negative 1 to the k times negative 1 to the 1. And then this would be x to the 3k times x to the 3. Just kidding, that one stays the same. My bad. Okay, the factorial can become k plus 1 times k factorial, and then we can start to cancel things out. So negative 1 to the k cancels, x to the 3k cancels, k factorial cancels. So on the top, we are left with a negative 1, which I guess I could have really ditched in the beginning because it's in an absolute value sign. We also have the k plus 2. And we have the x to the 3rd. On the bottom, we've got a k plus 1 and another k plus 1. So if you were to evaluate this using infinity, you have a k on the top and a k squared on the bottom. So this is just 0. We're not going to have the x to the 3rd, it's just 0. And 0 is less than 1, always. And so that tells you that t of x converges for all x, because it will always converge, and that the radius is infinity. So it tells you that. So we're going to say, so the function t of x converges for all x. Or you could even say converges absolutely for all x. For points, there's 2 points for this problem, 1 for using the ratio test correctly, and then 1 for the answer. And they added an extra little sentence. They said that this right here would be true for all x, and therefore you can make this conclusion, and so you probably do need to include that, that this is true for all x. All right, part B says to let w of x be the Taylor expansion for x squared times the derivative of f of x about x equals 0, so the center's still at 0, and find the general term for w of x, and then find w sub 3 of x, so that's the 3rd term. So I went ahead and I wrote out the terms for f of x that they had given you. F of x and t of x are the same thing. And I went ahead and I wrote out the general term as well, because it helps me to do that kind of as I go and apply other things to it, like when we're going to be doing the derivative and stuff like that. So the derivative of f of x is 0 minus 6x squared plus 18 divided by 2 is 9, x to the 5th, minus 36 divided by 6 is 6, x to the 8th. And so this negative 1 to the k. So we're going to have this k plus 1 is going to be multiplied by 3k. And then the exponent of x is now 3k minus 1. And then I went ahead and said, okay, now let's take this and multiply this in the front by x squared. So negative 6x to the 4th plus 9x to the 7th minus 6x to the 10th plus So the x, it was 3k minus 1, but since we're multiplying it by x squared, now we're going to be saying plus 2 to it. So then I was able to just kind of write the notation of my answer. So w of x is, and you have to remember to put that summation in the front. So as k from 0 to infinity, and I said negative 1 to the k plus 1, 3k, and then x to the 3k plus 1 over k factorial. And that the first three terms, negative 6x to the 4th plus 9x to the 7th minus 6x to the 10th. So for this one, there were 4 points. One was for the expanded form of the derivative. So this part right here, I guess you've shown your work there. The general term of the derivative, so right here. Another point for the general term of w of x, and then 1 point for this, so 4 points. So 1, 2, 3, 4. All right, part C. So this one says that the real function evaluated at 0.5 is approximately the fourth term evaluated at 0.5, and the real function evaluated at 1 is approximately the fourth term evaluated at 1. So find the values of those. So t sub 4 of 0.5 is going to be 1 minus 2 times 0.5 to the third plus 3 times 0.5 to the 6th over 2 factorial minus 4 times 0.5 to the 9th over 3 factorial. And so when I plugged that in, I got 0.772. And then I did the same thing with 1. And what I got when I plugged that in was negative 0.167. And for points for that one, you only get 1 point, and your 1 point is that both your answers are correct. And then part D says which value is smaller. And so this is getting at that error bound part of this. So f of 0.5 minus t, so the actual function evaluated at 0.5 minus the approximating polynomial evaluated at 0.5. There's 2 different ways of doing this problem. So I'm just going to kind of show you what I did here and explain both ways. So what I did is I said that f of 0.5 minus the approximating function at 0.5 has to be less than the 5th term. And the same thing with 1, has to be less than the 5th term. So what I went ahead and did is I figured out what the 5th term was based on that little formula they gave you, and it's 5x to the 12th over 4 factorial. And so then I went ahead and plugged 0.5 in, and I plugged 1 into C to just compare the numbers. And that is one way of doing the problem, and you get 2 points for that. And so the one that is smaller is the one with a 0.5 in it. So that's your answer. This could be your reasoning. The other way, since the notation that they gave you there represents the error, and since 0.5 is closer to the center was 0 versus 1, then we know the error is going to be less. The error is going to be smaller the closer you are to that center. And so you could just say, knowing what you know about how these work, that then 0.5 would be the answer. And so, and that was the other way you could do the problem. So either way is totally fine. This one might be the one that's a little bit easier to remember. It was like, as soon as I did that, you can see it says 5 point something, but it's e to the negative 5. So that's scientific notation for a very small number. It's 0.0005086. It was only after I did this that I thought of it this way, and I was like, I totally could have just done that and saved myself some time.